Welcome! In this first video, we're going to answer a simple but essential question. What exactly is a process? This might sound basic, but understanding what a process really is will help us later when we're using the Windows debugger to investigate crashes. Contrary to what many people think, a process is not just code that's running. It's better to think of a process as a container, a structured environment created by the operating system to run code. Inside the container, you'll find threads. These threads are actually workers executing the code. Each process must have at least one thread to run, and in many cases, it has several. So for a little demonstration, we're going to use the Windows debugger. And I'm going to attach the debugger to the process, meaning Notepad will be paused while we read its memory content. At the bottom you can see a progress bar and files being copied. These are called symbols files. They're a residue from compilation and they help us later on in debugging. And as you can see here, anti-DLL exclamation mark, and then there's the name of a function within that DLL. If symbols would not be available, this would just be the name of the module and an offset added to the end. Offset at where the function starts in memory relative to the start of the module. So it's of great help, and Microsoft chose to provide them for everyone. And the Windows debugger automatically downloads them as needed. Now in previous versions this wouldn't happen automatically. You would need to run the symfix command. I'll leave it in the notes in order to download the files. Now this is the memory contents of a single process. We see down below stack. It's something I'll discuss in future videos. And over here there's a bunch of information about the process it connected to. You can actually see the symbols it downloaded. There's a command called pep, process environment block. It shows you the object in memory containing the process definition. So object in memory means, well, it's a bunch of ones and zeros stored in memory. And in order to translate this to information, you can see here, you need to be aware of what's stored in there and what structure and how to interpret that data. So pep actually just reads the memory starting from this process and then passes it into the object it's expecting there. So that's why you can see readable information. When we have a look at it, there's a few things that stand out. Image base address is the address where the main executable is loaded in memory. So the file you clicked on. There's LDR, which stands for loader. It's the location where the list of modules used by this application is stored at. And we could actually see it if we type lm, list modules. This shows the executable and all the DLLs that were loaded when starting this process. So this is everything the process depends upon to run properly on your system. Now, as you can see, it's a bunch of things that might not directly seem related, but in order to display Notepad on the screen, the application in Underwater needs to talk to the Windows kernel in order to show a window, draw it, render it, make it draggable, things like that, make it run in background. You can think of other functionalities that are shared between the operating system and an application. For instance, saving and loading a file, network access, memory access. So there's a bunch of Windows DLLs loaded in here, and they're completely necessary to run an application properly. Back to the process environment block. We discussed the loader. Now, here's the list of modules in a nicely written format. You can actually see where they're stored. Starting addresses of a heap. Process parameters are the parameters the application is started with. And then there's the environment. The environment are variables set system or user-wide in the operating system. So for instance, if you'd refer in a command line script to percentage when there percentage, you'd always get this variable. So things like these are available in the context of an application's execution as well. In the next video, I'll dive into the threads, what they are, what they do. For now, it's okay to recognize them as paths of execution within a running process, and must be at least one, could be multiple. Now, I'm detaching the debugger. In case I stop debugging, the application would also be closed. So detaching it makes it run again. To wrap things up, a process is an environment. The code runs in threads inside the process. Debugging starts with understanding the structure before diving into the details. This foundation will make it easier to follow along as we move into real-world debugging examples in future videos. If you found this video helpful, please give it a like and consider subscribing to my channel. I'm doing this to share what I've learned and to keep improving as I go. Your feedback is really appreciated, so feel free to leave a comment with any thoughts or suggestions. Thanks for watching and see you in the next one.